Hi and welcome. Thanks for joining us for our April online webinar. In this webinar we'll be looking at Edge PLM productivity tools. Now this is a set of tools that Edge PLM has developed basically to enhance Solid Edge and just give you more productivity. There's four particular tools. There's a Schematics Extender, Cloud Generator, Quick Library and document numbering. We'll explain each of these tools as we go, so sit back and enjoy and just see if any of these tools can provide particular productivity for you. So we're going to start with the Schematic Extender. First thing we'll do is open up an existing schematic drawing. Now as you can see, this is a rough schematic for a mini excavator. We've got a hydraulic pump, we've got pressure relief valves, we've got a pressure indicator, we've got 3 controllers, and we've got a series of rams attached to those controllers, each with their own relief valve. Now we want to be able to generate a full schematic, or we want to extract all of the schematic information from this draft. So we've got a tool here, Schematics, and we can extract all of the information out of, for example, the blocks themselves. Now there's 2 extra properties here. These are stored in those blocks and they show up, and you can include them or exclude them from your block list if as you desire. Next you've got your table options. This controls where it's going to put the tables. We'll move on to our occurrences table. This allows us to select one or more block occurrences that we want detailed information for. For example, each of the pressure control valves that we've inserted, it prompts us to tell it what pressure that particular valve is going to be set for. So I want to now create a block or a table listing the pressures of each of those pressure control valves. And again we've got all of the options for laying out the next table. Lastly, we've got the connections table. Now this allows us to control how connections to a particular block are determined. We can use block range connections, that is, anything that falls within the block definition is considered to be connected to it. We can also use what's called block label anchor connections, and where, for example, you've got various pins on a component, you can give them names and it will determine which of the pins it is connecting to on that component. Now some things like, for example, pressure, which is a label that we've got on the valve controls, we don't want to be considered as a block label connector, so we can exclude them or we can include ones that we do want. Lastly, you'll notice down the bottom here, with each of these blocks, I can choose to write the table out to a file, be it text or comma delimited text, of a particular name. And we get to choose which of these options we're also going to create. So we're going to just continue with this, and you'll notice that it's quickly generated the tables, and also in the line type definition, this is what this allows us to set different line properties meaning different things. So we can set up a key table. In this case, I've got that a 0.5 mm continuous black line or black-white line means it's a hydraulic 50 megapascal line with a diameter of 20 millimeters. Now if I want to change that, It's quite easy. For example, I might want to change that to 18 millimeters. If I just accept this, it will go ahead and create that. However, if I want all of that type of line in the future to mean this particular definition, then I can update my line type library, and that will use that particular definition in the future as well. Now I'm just going to move that line type key over, and you can see it's given me a line type key, i.e. type 1, which refers to the type in the connections, and all of the connections in the schematic. Over this side here, we've got a full component list, and this has pulled out the mass and the stroke from each of the blocks has been used, and it's propagated them with that. Now we've also got the block occurrence table. We wanted the valve pressure controls and the pressure that each of them was set to. So you can see that one of them has been set to 31 megapascals and the rest have been set to 35 megapascals. Now what happens if we update this quite significantly? Well, we might want the bucket RAM to be a smaller RAM than all of the rest. So I'm just going to select that, right click, and I'll replace. I don't want to use the analog, I want to use a cylinder 3S. And you can see you can have different libraries as well. You can have the active document and a different library selected. I'll just use the 3S cylinder, and you can see it's a smaller part. Now I might want to update the layout of this as well. For example, this RAM, or the boom RAM, at the moment there's 2 boom RAMs. I only really want 1 boom RAM. So I'm just going to delete that connection, and I'll move this one down to connect up. I'll move the title down as well, and then all I've got to do is simply hit update. It goes away, updates. You'll see it's added the cylinder 3S in there now. It's also reduced the number of cylinder 3s to only 2, and it's updated the connection table as well. So very, very quickly, once you've set up, it can handle the modifications that you might need as you go down the track. You'll note also it's updated the item numbers on all of the components. So that's just a quick look at this type of schematic extender, and some of the things it can basically just take away some of the time that you would normally spend. Now it has one other quite useful functionality as well. I can set up the schematics in my templates before I even start a document as well. So here I'm starting a new document based on my schematic template, and you can see that I have all of my tables laid out in this document ready to go. So we'll just start by creating from scratch an electrical circuit this time. We've already had a quick look at hydraulics, so this time we'll do electrics. And I'll just zoom in a little bit. I've got a battery, I'll place that. Notice it prompts me for the voltage as I place it. Next we'll put a motor in, and I'll place the motor down here. No values needed for that. If I wanted, I could add, for example, something like wattage, and we want a switch in there. Now note, I can bring these around quite easily. I'll just put my switch in there, and I'll put a resistor in for the sake of it. And again, with the resistor, it prompts me for a value. Lastly, I'll just throw a diode in there because we want this, oops, goes that way. We want this to not blow up or short across the switch when we turn it off. Then we'll just use, for example, a connector, and I'll make these black to start with. So you can see that it's quite easy to line up my connectors. And flow them through. Now I might want different, size wire, and that can be represented by a different width or even just a different color. So now that we've got our circuit, we might want to, move it around. You can see I've sort of made a bit of a mess of it. It's not very central, so I can just move my components around a little bit. So there we go. Now all we need to do, because we've already got the tables in there, is I just need to update. And you can see that it's pulling the different wires out of the library already. It hasn't filled in the connector or the capacitance table for a good reason. There's no capacitors in there. However, it's got all my quantities and all of the values of everything else. Now you'll notice here junction 2 is listed on this side connecting to motor item 2, and it's also listed on this side. This is a function called both connection directions, and you can turn it off if you don't want it. Then you just need to update, and you see the table update as well. We give the option for that because it makes finding connections to particular components very, very quick and easy. So that's just a quick look at some of the tools we've got for schematic connections. Alright, so now I just want to have a look at one more file. Now this is one that I've already got done. So, and this is a file just to quickly demonstrate the use of the cloud macro or the cloud generator. Now here's a drawing of a door. It's all completed and it's all finished. However, if I should go and make a change to this, I'll just click on the dimension, bring that down to 400 millimeters. What happens to the draft? Well, we all know that it's out of date and it needs updating. So we'll just simply update views, and you're all quite familiar with the dimension and revision tracking tools. So I'll just clear these annotations, and two of my values have changed. Okay, I'll just close them, and now what you get are these revision balloons basically. However, not always are these revision balloons what's desired. Sometimes you just simply want to have a cloud, and it depends on the drawing standards that you're using. So what we'll do is we'll come in to the track dimension changes. I'm going to create a new revision, and the label will just be 3 for both of these. Now what we can do with these is when I select them, you'll see I can choose the shape. One thing that is not here is a cloud, and it is specified in some standards. So we've just created a very simple tool. All you do is you draw a cloud. It can be as rough or as close as you want, and then you simply select that cloud and say whether you want that to be turned into an internal cloud or an external cloud. If these settings are too large, you can come and change the options. We'll just go for an external cloud of 4 mil. We'll go half, and it automatically updates the arc height down to 2 mil, and then we'll just create an external cloud using the 2 millimeters. Now these clouds can be moved around, selected at will, and basically that's what the cloud revision or the cloud generator is. It's just a tool for quickly generating cloud shapes which follow whatever shape you happen to have sketched, just basically to allow compliance with some certain drawing standards. So next we'll be looking at the quick library. Now this is a tool to basically just enable rapid reuse of components. So we'll just start off. As you can see, I've got one steel components in there at the moment. I've got standard parts and standard assemblies. Now these are three different styles of parts that Quick Library can use. The one steel library is a library of different sections, and it will create the appropriate sized or appropriate length component of that section size. So we've got a sort of a wall cupboard here. It might be off a train or an ambulance or something like that. Now we want to put a handrail on, so the first thing we'll do is we'll just create a length of 1800 millimeters of the CHS. It brings you in here, and as you can see, it gives you the standard dialog box for placing it once it's in place. So I'll just now add a tangency and another tangency, in this case maybe 150 off the front face, and I just need to flip that one there so it's sitting next to the edge of the component. Next we'll put in a door. Now a door is something which is much larger than just a single component, and we'll use a door assembly out of the standard assembly library, and I have two options. I can place the original, or I can place a copy of it. In this case I'll just place the original into the assembly, and you can see that again it's just given us the normal dialog box for positioning this assembly. And I'm just mating up these constraints. Alright, so our door is positioned here, but as you can see it's quite a different size to what we need. We'll just use solid edges, replace part with copy, and what this will allow us to do is very quickly just create another copy of this assembly. Now in this case I'll bring it up and just door assembly for locker. Save that, and I need to have a different door in there as well, so I can just do exactly the same thing and lock a door. So that now I've still got my original assembly, and I'm now ready to basically edit. You'll notice that this door doesn't quite fit, so what we want to do is we want to modify this door with to give 2mm clearance. Oops. And then we'll just drag it back to the vertex there. Now don't worry that it hasn't changed it, because we just need to relax this dimension and then it makes that change, and we've got our 2mm clearance there. We also need to do a similar thing for the height of the door. So we want to bring the bottom edges of this part, as well as these holes obviously, and we want to give it a 2mm clearance again. And just bring that up to this edge, and obviously we're going to need to relax the 420 so that we can do that. Now you'll also notice that these holes are now out of alignment, so we'll just bring them up to alignment as well. So now our door completely fits, and we've rapidly reused a lot of the work that went into creating that door assembly for a new door. So the next thing we want is we want some clamps onto this post. Now remember, it was a 26.9mm diameter post, and we need some clamps on it. Now in our quick library we have a series of standard parts and we have standard assemblies. However, one other thing that we want to add is we want to add a new library for what we would call semi-standard parts. And these are parts that are basically changed every time they're used. The intelligence of the part is the same, but they get changed every time. So we'll just browse to our library, and semi-standard parts. We want to enable the placement of the original, a copy, or a copy, which means we want to allow both types of parts. So I'll allow both PAR and PSM. So I'll add that library in. As soon as I hit save, it will update and grab the new parts, and it will add them to the library. So we've now got semi-standard parts, and I'll grab a sheet saddle, place a copy because I want to be able to modify it, and I want the plane to go there, and I want the bottom one to be 100mm off the floor. Now what I need to do is I need to make sure that I've got the same diameter, 26.9, And all I need to do is go into my flange and select 26.9, and yeah, 30mm is probably a good depth, although I could drop it down to 25 if I want. When I've got that, then I just need to fit it and add a second one. So very quickly I've generated custom components, reused existing knowledge, and generated my parts. So what happens if I now want all of this to be numbered according to my system? Well, first of all, let me go and enable my numbering add-in. You can see it here. I have an option to perform what's called an assembly allocation. Now this is a nice little tool that enables me to allocate document numbers to existing components. Now some of these components are already numbered, so it skips them. I can number them if I so choose. The ones that need further information, I just need to go and say whether it's a structural member, for example, and then you see it's got all the information it needs. The door locker, it's a casing. I don't really want to number all of the Southco parts. So you see I can skip them. Some numbering systems, depending on whether you want user input or not, will automatically number if there's no user input required. So once all of my documents are set up and have the information required, I can just go and perform the allocations. And you can see it down the bottom, it's allocating those numbers. Now, depending on how your options are set up, you may or may not see anything initially. You see down the bottom, I've only got my file name showing at the moment. However, I can add, for example, the document number in, and then the allocated numbers show as well wherever they're allocated. So it's quite a powerful system. Now this is how it works with existing documents. Where I want to create new documents, I'll just save this. Where I want to create new documents, it gives me other options, and that is I can number my parts before I even have created them. I can just skip this if I want, or I can select whether I'm creating a structural, casing, electrical, hydraulic, reference, whatever you choose, however you set up your numbering system. It's a very flexible numbering system. It will then save this document and fill in the properties, and you're then ready to start working. So thanks for watching. Now you've seen some of the Edge PLM productivity tools. Hopefully you can see a place where they can assist you and just increase your productivity. The next clinic we've got on, we'll be looking at an introduction to ExpressRoute. This is a piping and tubing tool. It's quite a powerful tool. That'll be on the 29th of May. If you've got any questions, by all means review this webinar online at our Edge PLM YouTube channel, or you can email support@edgeplm.com.au, or you can call us on 1300 883 653. Thanks for watching.